Hi class, here we are again. Only now we're going to look at the analysis of consumer demand price effects instead of income effects. And we're going to be following pages 46 to 53 in your textbook. When we look at the own price effect, we're once again doing comparative statics. That is, looking at our basic model where we plot a budget line and our preferences or utility, and we find a point of equilibrium where the budget constraint and the indifference curve have the same slope, so that the marginal utilities of the budget constraint, or the ratio of the marginal utilities, is equal to the ratio of the prices. And that is where we find our point of tangency and equilibrium for a consumer. This consumer with this particular set of preferences. U1 demands QF1, quantity of food, and QO1, quantity of other goods. Now, last time we looked at what happens when income changes. We changed income. Now we are going to change the price of the good on the horizontal axis. We are going to change the price of food. Now, the price of food doesn't have anything to do with the y-intercept, so that y-intercept will stay where it is. The slope will change, because if PF goes up or down, you'll see that the slope, which is negative PF over PO, will change. And of course, our x-intercept will change, whereas the x-intercept is y over the price of food. So let's say right now we're going to decrease the price of food. If we decrease the price of food, of course, that x-intercept will get bigger. And of course, if we decrease the numerator and hold the denominator constant, the slope will also get what? Smaller. So the budget line rotates around the maximum quantity of the good whose price doesn't change, and rotates out because prices went down, and this individual consumer or household can purchase more given a set amount of income. So what's going to happen? We can look at the total effect for this set of preferences. It's still preferences U1, but since our consumption possibilities went up because we relaxed our constraints, our consumption possibilities are maximized at a different place. And so we see this consumer, the way this is drawn, will actually consume a little more food and a little more of other goods. This is the total price effect. The total price effect says what happens to the quantity of food purchased, or a change in quantity given a change in price. And in this case, as price went down, quantity went up. Later, we're going to see that we can decompose this total effect into something called a substitution and an income effect, but we're not there yet. So we will get there in the next video. So even seeing something like the change in the quantity of food given a change in price should bring you back to something called elasticity, or a 1% change, this time in price, leads to an X% change in quantity demanded. But this is only part of the equation. Just as with income elasticities, if we multiplied this by price over quantity, we would get a price elasticity. And again, this piece could have the original prices and quantities, point elasticity, the new prices and quantities, point elasticity, or we could calculate an arc elasticity using the summation of the prices and quantity. Again, the own price elasticity of demand for a good is the absolute value of the percentage change in the quantity demanded of the good due to a 1% change in its price, holding other prices, income, and preferences constant. So just as we did with income elasticity, we said QF2 minus QF1 over P2 minus P1 times, and let's use original prices and quantities here, is going to equal the price elasticity of demand. Notice also in that definition, I said absolute value, and that's because we really do expect price elasticities to be negative. That is, when we increase the price, we will decrease the quantity demanded, and when we increase the price or decrease the price, we will increase the quantity demanded. So just as we did with income elasticity, we know that we're going to need two prices and two quantities in order to calculate a price elasticity. So what did we say in our original diagram here? We said that we decreased the price of food. So let's say the price of food at the beginning was $8 a unit, and it decreased to $5 a unit, and at $8 a unit we demanded 10 units of food, and at $5 a unit we demand 15 units of food. So we say Q2 minus Q1 over P2 minus P1, P1 over Q1 is equal to the point price elasticity. And we'll just say 15 minus 10 over 5 minus 8 multiplied by 8 over 10 is equal to 5 over negative 3 times 8 over 10, or 40 over negative 30. And that equals 1.33. Negative 1.33. So calculating this point price elasticity of demand at negative 1.33 says a 1% increase in the price of food leads to a 1.33% decrease in the quantity demanded, or we decrease price this time, so we can say a 1% decrease in the price of food leads to a 1.33% increase in quantity demanded. So when we decrease the price, we increase the quantity. When we increase the price, we decrease the quantity. And why is it that we say we can use the absolute value, which puts everything on a positive scale? Because only for a certain kind of goods, called Giffen goods, do we increase the quantity demanded when we increase price. We always expect quantity to go down when price goes up, and quantity to go up when price goes down. Now, again, if you recall from our discussion of income, we derived an angle curve from our preference map. And on the angle curve, we had income on the vertical axis and the quantity of food on the horizontal axis. Now, we're going to put price on the vertical axis and the quantity of food on the horizontal axis. We are going to derive a demand curve, which you've all heard about in even your most basic economics classes. How can I derive a demand curve from a preference map? Well, quantity of food, quantity of other goods. Here's a budget constraint at a certain amount of price and income, and I have an equilibrium, and I get QF1, and then I say perhaps I decrease the price, and I have another point of equilibrium, QF2, and then let's say I decrease the price of food further, and I have a point of equilibrium, QF3. And at this black budget line, I have the highest prices. 1, 2, 3. Price is highest. This green, or the red in the middle, is price medium, and right here we have the lowest prices, and that's P3. That could be confusing, but just remember, the farther you are in towards the origin, the higher the prices, because the higher the prices, the more constrained you are. The farther away out the budget line is due to low prices, the less constrained you are, and the more you can buy. Just as we did with an angle curve, I can come down, and at price 1, the highest price, I demand this quantity. At those medium prices, I'm at that red line, and at the lowest prices, I'm at the green line. QF1, QF2, QF3, corresponding with the same quantities as I had on my preference map. I connect the dots, and lo and behold, I have a demand curve. We always expect demand curves to be downward sloping, and again, that's because when we increase the price, we expect quantity to decrease. So that means less than 0. This was a short little video. We went through a lot, and we will pick up here next time.